Alright, so in this video, I'm going to solve the equation 9 to the power of x plus 9 to the power of x plus 9 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 9 to the power of x on my left-hand side. So I get 9 to the power of x times 1 plus 1 plus 1 is equal to 999. Now 1 plus 1 plus 1 is 3, so I get 9 to the power of x times 3 is equal to 999. From here, I'm going to divide both sides by 3. So these two cancel out, and I get 9 to the power of x is equal to 999 divided by 3, which is 333. Alright, so from here, I'm going to take the log on both sides. So I get log 9 to the power of x is equal to log 333. And if I have something in the form log a to the power of b, this is equal to b times log a. So log 9 to the power of x, I can move the x to the front. So I get x times log 9, which is equal to log 333. From here, I'm going to divide both sides by log 9 because we obviously want to isolate x. So these two cancel out, and I get x is equal to log of 333 over log 9. Now, I can rewrite log of 333 as log of 3 times 111. And I can rewrite log of 9 as log of 3 squared. Now, we know that if I have something in the form log a to the power of b, I can move b to the front. Another property of logarithms is that if I have something in the form log a times b, this is equal to log a plus log b. So I get x is equal to log 3 plus log 111 over 2 times log 3. And this is equal to log of 3 over 2 times log 3 plus log of 111 over 2 times log 3. So now these two cancel out, and I get x is equal to 1/2 plus log of 111 over 2 times 3, log 3. So now log of 111 is equal to 2.045. So I get x is equal to 1/2 plus 2.045 over 2 times log 3. And log 3 now is equal to 0.301. So I get x is equal to 1/2 plus 2.045 over 2 times 0.301, which is 0.602. So now log of 111, which is 2.05, divided by 0.602 is equal to 3.397, which is the same thing as 3.40. So if I add 1/2 to this, I get 3.90 as my solution. Alright, so in this video, I'm going to solve an interesting exponential equation. So my equation is 100 to the power of x is equal to 400. And I want to find the value of x. So we see that x is going to be in between 1 and 2 because 100 to the power of 1 is 100 and 100 to the power of 2 is 10,000. So it's going to be more closer to 1 than it is 2, but it's going to be somewhere in the range of 1 and 2. So to solve this, what I'm going to be using is logarithms. So I'm going to first start by taking the log on both sides. So I get log 100 to the power of x is equal to log 400. And if I have something in the form log a to the power of b, I can move this exponent of b to the front, so I get b times log a. In this case, I have log 100 to the power of x. I can move x to the front, so I get x times log 100 is equal to log 400. Now, I'm going to take the log of base 100. So, log base 100 of 100 is just 1. And log base 100 of 400, well, 400 is the same thing as 100 times 4. So I can rewrite this as log base 100 of 100 times 4, which is equal to log of 4 over log of 100. And I have 1 plus this because of this. So now log of 4 is the same thing as log of 2 squared. And log of 100 is the same thing as log of 10 squared. So I can move the 2 to the front and the 2 to the front over here. So I get x is equal to 1 plus 2 log 2 over 2 log 10. These two cancel out, so I get x is equal to 1 plus log 2 over log 10, which is equal to 0.301. So x is equal to 1.301.